Hey, ladies and gentlemen. I just wanted to go over quiz 4.1 with you and just to help you along with some of the reasons for the grading and some of the things I'll be looking for, as we look forward and prepare for the test at the end of this week. So quiz 4.1, I can't say enough about chapter 4 in general and just the terminology. There's so many vocab terms. I think there's 40 plus on the Quizlet. Please do not assume that you got a 100% on the Quizlet, that means you're good for the vocab. You really need to know this stuff, and there's a lot of terms, and it's all coming really fast. So the first two terms that are crucial for the whole course and just understanding what even is going on in statistics are these two terms here, the population versus the sample. And so if you've done the reading, which I hope you have, make sure you're doing the reading and really understanding how all these terms are coming together. The population is everybody. The population is the people group or the individuals or the whole animal group or the whole region or the forest or the types of trees or all, whoever the answer to the question is, what do we want to know about? Who are we studying? That's our population. It's everybody. It's everything in that group. Now, populations can be big, obviously. In the year 2020, in the United States, for instance, we're supposed to have a census. That's the study of every single individual citizen of the United States. That's a population. We get a population survey, and that's a huge population. Obviously, where I'm living right now in Pennsylvania, the population is much smaller, but it's still a valid population if that's all I care about. So the question has a lot to do with what do we care about? That defines your population. And then because of the fact that populations are so huge and so many people or things are involved in that, we rarely have access to a census. We rarely have access to get that kind of information. So in statistics, the name of the game of statistics is collecting a valid sample. We can't get everybody. So all we can hope for is a good representative sample. That is key. And that's what statistics means. It literally means what is a description of the population that we got from a sample. And so chapter 4 is all about getting good samples and knowing the difference between a sample and a population and knowing exactly how that all works. So these first couple of questions are just trying to tease out difference between the two. So you got part A, a business school teacher wants to know what factors affect the survival and success of small businesses. She selects a sample of 150 eating and drinking establishments, that's restaurants, from those listed in the telephone directory. So assuming people still use telephone directories, we can assume that the population there is all the eating and drinking establishments or all the restaurants. That's fine too. If you use restaurants here because you recognize that eating and drinking establishments are restaurants, that's perfectly fine. All restaurants in the large city. So notice I didn't stop at just saying all eating and drinking establishments. I didn't stop at saying all restaurants because then I would assume we're talking about in the whole world. We have to be specific about what our population is. All the restaurants in this large city. And it is important to have the word all because we're not just saying the population is some restaurants. It's all the restaurants in a specific area. So population is everybody in the specific confines of what we care about. In this case, she cares about this large city. Okay, and so again, there's a lot of things that go into that, but 1 point since we're only going to have 20 points in the quiz. All right, next one, a member of Congress. Again, a United States type question, but Congress is one of our governing bodies in the United States. Elected people go to Congress and they represent their constituents. So although these are not vocabulary terms, it is important to know what in the world they're talking about. Congress is just an elected position. Constituents are the people that you represent when you're elected to that position. So you think about RVA student government. Who's up there? Is Unsu one of the people that was elected this year? I think so. He's in Congress, let's say, and he has constituents. His senior class is his constituents, the people he cares about, the people he wants to represent well in as he rules. Okay. So he's supporting legislation on healthcare. His staff reports that 228 letters have been received on the subject, of which 193 oppose this legislation. So there's some law that's coming by. All we want to know about is who's the population in this scenario. And we have, without using the word, we have a sample right here. 228 letters came in. Obviously, somebody decided to write a letter. In fact, 228 somebody's decided to write a letter, and they sent it in. And out of those 228, 193 of them felt a certain way. So the vast majority, I don't know, 80% of them, decided we don't really like this law that is about to be passed in Congress. And so that really is the proportion that we're going to get to. That would be a sample p-hat. That would be later in the course. We'll talk a lot about this. This is the result of our study. We found out that 193 out of 228 opposed it. But that's not what the question is asking about. The question is asking about who do those 228 people represent? That's a sample. That's a certain number of people. Not everybody wrote a letter. Who do they represent? They represent all the constituents, all the people of this member of Congress. Okay, so it's not all the constituents only, because then who are we talking about? All the constituents of what? All the constituents of this member of Congress. All right, number 2. Local radio talk show host asked viewers to call in and to vote for or against the proposed plan. Okay, 75% of the respondents are opposed to the increase in parking meters. Describe one possible source of error or bias that might arise in this poll and indicate the direction. So bias is a huge, huge concept here. Bias is not opinion. Well, that's your own personal bias. We use it like that in how we talk, but I don't want you to use it like that in AP statistics. I want you to use it as bias is the overestimation or the underestimation of reality. Bias is, it represents how far off of the reality our sample is and in which direction is it off. So here we care about the people in this town or in this viewing area, the listeners of this radio station. We care about how many of them propose or oppose this plan. What is the proportion of people? What's the percentage of people that don't want it to happen? And so there's a true number out there, right? If we could ask every single person in the whole city or in the whole state or wherever we're talking about here, we would have a real answer. Bias, though, is what is going to creep in based on his sampling method. What is this person's sampling method? He decides he's got a radio show, got people listening to him, and he says, go ahead and call into this radio show and tell me how you feel. That's what he's saying. He's only talking to his listeners, so that's not the whole population. And he's only asking them a question that he's probably been talking about, right? He's a radio show host. What do? They talk, they tell their opinions. So there's a good chance that they're going to agree with him. And that's where the bias comes in. My answer here, the model answer, it doesn't have to be exactly like this, but people who disagree with a proposal that will cost them more money are more likely to call in and express that opinion. So you think the proposed plan to raise the prices is fine, then what do you care? You're probably not even listening to this talk show host. You're not going to call in. But those that did call in, 75% of them were opposed. So what we think, what we assume is that 75% is an overestimation. Because, one, you could say it this way, most of the people that are going to listen probably are going to oppose this because the local radio talk show host asked them whether they would oppose this plan. He didn't ask them how they felt about it. He said, are you for or against this plan? And he probably has his own motives. That's maybe not as strong of an answer. The better answer is someone who is opposed to something is more likely to try to stop it. So those are the people that are more likely to call in. So if we had a true picture of the whole thing, there's a good chance that the people opposed to it are less, or that our result is an overestimate of the proportion of people who feel this way. And the type of bias that we assign to that, another vocabulary term, is voluntary bias, voluntary response. Because they were given the opportunity to call in or not, only the people that care are going to call in. That's voluntary response. And the next one, 2 different organizations conduct polls in a city whose mayor has been accused of taking bribes. One poll asks, do you think the mayor should resign because of accusations of his criminal activity? The other poll asks, do you think the mayor should resign? So the first poll concluded the majority of citizens thought he should. The second poll drew exactly the opposite. Explain why the results might be so different. And so this we call response bias, and it's based on the wording of the question, right? This one added this. The question actually had the reason in it. Do you think the mayor should resign because he's been accused of being a criminal. The other question just said, do you think the mayor should resign? So it's like here they put it right in front of their face. They said, he's a criminal. He's got criminal activity or is accused of it. It's response bias based on the wording of the question. You can ask a question, do you think that abortion is a horrific murder of unborn children? Do you think that that's the case? Or you could say, how do you feel about abortion? Right? You can ask the same question in two completely different ways, and just based on the wording of the question, you can sway people one way or the other to answer a certain way. So the wording of the question explicitly mentions the reason for the resignation, putting that on the forefront of people's minds. Mentioning the criminal activity will produce a stronger negative response. And so there's the direction. Most likely the result we got is higher than reality, right? The bias here pushes people to answer yes more often than they normally would. And the bias comes from the wording of the question. In number two here, the bias came from the fact that people could call in an answer just based on the fact of whether they felt strong enough to call in an answer. That's a voluntary response. You're only going to get certain people to participate in that survey because they feel strong. So it's not going to represent the whole population very well. It's only going to be the people that really care. Whereas the other one, it was an SRS. It was not opened up to whoever felt like it. It was sent out to a random sample of people, and that was done the right way. But the wording of the question was poor. If we were face-to-face, we'd be doing a project in this chapter, and you would actually test this out. Is wording of a question actually a thing? Does it change people's answers? Every year, our students find out that absolutely it changes their answers. It affects the way people think if you word the same question differently. All right? So always mention the type of bias, there's your vocab, and always mention the direction that the bias is in. Again, not that it's wrong for people to feel a certain way. We're not talking about that kind of bias. It's not an opinion thing. It's overall, which direction from reality is the result we got from our sample. Because if they have bias, if bias is present, then the result we got is not a good representation of reality. We want a good representation of reality. We want our sample to match the population as close as possible. All right, number 4. Is this an SRS? Your school will send a delegation of 35 seniors. 200 girls and 150 boys are eligible to be chosen. If a sample of 20 girls and a separate sample of 15 boys are each selected randomly, it gives each senior the same chance to be chosen. Is this an SRS? The answer is no. An SRS is defined as, in this case, any combination of 35 would have the same possibility of being selected. And yes, that even means you could have 35 girls. It's possible that 35 girls could be randomly selected from a group of 350, right? And it's possible that a group of 35 boys could be selected. It does not have to be balanced in an SRS. So maybe that's not what you want, and that's okay. SRS is truly random. Simple random sample is the right kind of survey, except when we care about proportions, right? We want our sample to represent the population well, then we're going to maybe go for a stratified random sample instead, and that's what this is. So it's not that this is a bad sample. This actually might be a better sample because we want our female and our male population to be represented well. So it wouldn't really help if we sent a delegation of all 35 girls or all 35 boys, which could end up happening if we have an SRS. Let's stratify it first and pick, proportionally speaking, 20 girls at random and 15 boys at random, and therefore guarantee ourselves a good representative sample. Again, this is the reason it's not an SRS though, because an SRS would allow for any combination of 35 seniors. The method that they've chosen ensures the proportion remains consistent with what the population is. So I want you to be careful on this. Even though the answer here is no, it is not saying that this is a bad sampling method. In fact, it's probably better that they did it this way because it's going to guarantee that the proportion in the sample matches the proportion in the population. And that's a good representative sample, or at least it's on the way to it. So 2 parts to that answer. Part B, explain clearly how you would use your calculator to choose a sample of 20 girls for this study. So on the calculator, if you've got a TI-84, it's the math button and then the PRB menu. Move over to the PRB menu, that's probability. Number 5 is random integer. I think number 6 or 7 is random integer no repeat. You can use either one, but in this case, 1 to 200 is the parameters you would put in because you have 200 girls, and you do have to specifically mention this. Anytime you're going to do a random selection, you have to label the numbers that each individual represents. I have 200 girls, they should be numbered from 1 to 200. It's a little different down in part C. Notice in part C, I started off with each girl labeled from 001 to 200. Up here, it's 1 to 200. The number of digits doesn't matter with a calculator. It absolutely matters with a random number table, because how am I ever going to get a number from 1 to 9 if I don't use all 3 digits? So I have to specify down here 001, and I don't need to. It would be silly to specify it here, 1 to 200, but both of these are absolutely required for credit. Make sure you label the individuals in your study so that they can be randomly selected using chance process. And for back to the calculator here, we hit enter 20 times. It should give us 20 unique numbers. Unique is important there, because if they are not unique, if I hit the button, I get 37, and then I hit it a few more times and I get 37 again, that's not a unique individual. That's the same girl selected twice. We can't select the same girl twice. We need to try again, so we get 20 unique numbers. That's important. Down here with a random number table, it's a little different. We're going to start with line 108, and typically we go across the line like this, not down. It's just right to left. I'm sorry, left to right, just like you would read a sentence, okay? So don't go down, just go across. Again, make sure you're labeling ahead of time. Starting in row 108, select 3 digits at a time. So the first 3 digits I'm selecting are 609, the second 3 digits are 407, the third 3 digits are 202. Notice what's true about all those. They're not helpful. None of those numbers are in the range that I have. 417, not helpful. 868, not helpful. 249, not helpful. When am I going to get to a number that actually helps me here? This is my first individual that's selected because this is my range. 001 to 200, I finally got my first student. And the next 3 digits is 090, so there's my second student, and I want to pick how many. Select the first 3 senior girls. So I'm going to keep going. 656, no good. 879, no good. 641, no good. 883, no good. 336, no good. 009, good. So there's how I did that in order. I just keep following down into the next line, just like that. And I showed it here marked out very clearly. These are the 3 girls who would be selected, the first 3 girls who would be selected for my sample, okay? If you have any questions about that, please don't hesitate to ask. Sorry, this was a long video. Oh, I do have 4 more questions. All right. Again, sample versus population. To which of the following groups of trees would it be appropriate to generalize the results? In other words, who is the population here? This is asking who is the appropriate population, or which of the following are the appropriate population. I can't say all hemlock trees in southern Vermont because I didn't choose from all different places in southern Vermont, okay? I can't say all trees because it was only hemlocks anyway, and certainly not in southern Vermont. I can't say the 200 because that's the sample. This is describing the sample I chose. I can't say all hemlock in the United States for the same reason I can't answer A. I have to say that my sample represents all the trees in this specific forest, because there's going to be different things going on in different forests. And this I only chose from one forest. It's got a certain latitude and longitude. It's got a certain geographic, set of parameters. That's the only thing I can say. So E is correct. Number 2, which of the following is a method for improving the accuracy of a sample? This is one of the questions, one of the answers, one of the keys to this study, to this whole class. Larger sample size. If you can get a larger sample size, you will almost always guarantee a better sample. Wording of a question is obviously important, but this is not crucial. You don't need to limit yourself to 3 or 4 words. When possible, avoid the use of human interviewers. Nah, not really, because you're going to have to ask questions that are human interviewers a lot. Use smaller samples? Definitely not. Ask only questions for which the responses are quantitative, not necessarily helpful in every situation. This is the only one that'll work every time, for sure, using larger sample sizes. A bigger sample guarantees a better representative of the whole. Number 3, we say the design of the study is biased if which of the following is true. Again, this is important. Bias. Don't think opinion, think how far from different, or so how far from reality are we being? And this option here, right here, certain outcomes are systematically favored. So with the voluntary response, only the people that actually care are going to call in. With the wording of a question, we're pushing people to respond a certain way based on how we worded the question. Certain outcomes, certain proportions, certain responses are favored based on the way the sample was collected. Again, there's nothing wrong with the true opinion of the group of people that we're trying to get information from. That's good. They should have an opinion. We want to know what it is. We want to know what the true opinion is. What we don't want to do is conduct our study in a way that pushes people one way or the other, or only gets answers from a certain proportion of the people. That's the big problem. Random placebos is no good. The correlation is greater than, that has nothing to do with bias. And an observational study was used when an experiment would have been feasible. Also not really a bias question, okay? So this is kind of a standard definition. Letter C is a standard definition of bias. Number 4, a sample of a student opinion at Big Ten University selects a simple random sample of 200 of the 30,000 undergraduate students and a separate SRS of 100 of 5,000. What is the term for this kind of a sample? Very similar to the question we looked at earlier. We are only picking certain amounts, certain proportions of both of the groups. So they didn't want their graduate students to have a larger representation because there's many fewer graduate students. There's only 5,000 of them, so they only sampled 100. Whereas with 30,000, they decided to sample a few more, 200 to get a better representative. This is a stratified random sample. By the way, the difference between stratified didn't really show up here in the quiz, but it does a lot on the AP. Stratified versus cluster. Here's your key. This is some individuals from all the groups. Some from all, okay? That's what a stratified sample is. We took 20 girls and 15 boys. We stratified them based on gender, and then we took some from each of the groups. In this case, we took 200 of the undergraduate students and 100 of the graduate students. We took some from all the groups. Cluster would be, take the high school, split it up into 4 grades. We're going to randomly select one of those grades and take everybody. Cluster is all from some. It's exactly the opposite. We take all the people from only some of the groups. And it's just a turn of phrase, the difference between these two. If you cluster sample the trees in a forest, that means you're going to divide the trees into all these different regions, and you're going to go through and randomly select 10 of those regions and only go to those regions. So I picked region in row 1, column 3, that region got selected. I go and select every single tree. I measure the diameter of every single tree in that region only. And then I go down to row 6 and over to column 5, and I selected that region. It's not that I'm taking trees from every region. I'm only taking some of the regions, but I'm getting all the trees from some of those regions. I could stratify with the same example. I could stratify with a forest of trees. In that case, I would randomly select trees from this cluster, from this strata is what they call it. I would randomly select 5 trees from this cluster, 5 trees from this cluster, 5 trees from this cluster. I would have to go to every single group, every single geographic location, and have to take a few, some from all of the groups. This is all of the individuals from some of the groups. That's stratified versus cluster. That's a huge emphasis in this course and in this chapter. Okay, my time is up. If you stuck with me the whole time, well done, and have an awesome day.